Let's do another program. Remember, recursion is a skill. Watching someone solve a recursive problem over and over will help develop the skill in yourself. As mentioned in the previous video, we are going to go over the Fibonacci sequence and implement it as a function using recursion. What is the Fibonacci sequence? The Fibonacci sequence is a series of numbers 0, 1, 1, 2, 3, 5, 5, 8, 13, 21, 34, so on and so forth. The next number in the sequence is found by adding up the two numbers before it. The 2 is found by adding the two numbers before it, 1 plus 1. The 3 is found by adding the two numbers before it, 1 plus 2, and so on and so forth. Let's start with the actual formula. F of n equals f of n minus 1 plus f of n minus 2, and so on and so forth. This leads us into our need for a base case. Remember, base cases are necessary in order to provide concrete values for the function's terms in the recursive cases. What is the base case for this scenario? When do we want our function to sum up all the activity and return home? Well, I mentioned in the previous video that when our function passes in either 1 or 2, then we should be able to finish up our process. Let's start with the actual formula. We have f of n equals f of n minus 1 plus f of n minus 2. In this example, we will be adding each of the values when the function call returns the stack frame after it has reached its base case. Let's start with the program and walk through it. Okay, so I am going to call my function fib and we'll return an integer. And we're only going to pass in one integer at a time. So n minus 1 is only one number, so we'll just say integer n. And we'll need our curly braces, of course. So again, a recursive function continually calls itself within the function. So we will want to return our function by calling itself. What was our function definition? We had f of n minus 1 plus f of n minus 2. So we're going to call fib n minus 1 plus fib n minus 2. Don't forget your semicolon if you're using C++. Okay, now we already know that if we don't have some sort of base case that this is going to call recursively forever. My compiler is trying to tell us that. So what was our base case again? Our base case was as long as n was greater than 1 or 2, we wanted to return the function call. However, if it was less than 2, then we wanted to return n. Okay, now when I call Fibonacci, we should see, when I pass in the number 9, we should see 34 as our output. Oops. Let's run our problem, and we'll see our answer down here. There we have it. We have 34. So let's look at how this is working. Let's start with a smaller number, though. So we pass in, let's pass in a 3. Or let's do a 4. So we pass in a 4. And so n equals 4, and we're saying if n is less than or equal to 1, so it's not that, let's jump down to the return. And then we call Fibonacci again, and we say 4 minus 1, so that's 3, plus 4 minus 2 equals 2. Then it's going to call that for both of those numbers. So then we're going to, for Fibonacci n minus 1 equals 3, we're going to then go and get both of those for 3. And then for 2, we're going to go get both of those for 2. And then once we hit 1, boom, we're returning n. So now we're returning that. And then we're going to, every return is going to add both of these together. Whatever this returns, it's going to add to whatever this returns. And thus adding all of those together. And it kind of makes a little tree. So taking a look here at this tree, you can see that if I put in 4, it's going to tree down all the way to 1 and 0, tree down all the way to 1 and 0, and it will return the added value each time. So that is a little peek into some more recursion for the Fibonacci program. Thank you so much for walking through this brief introduction to recursion with me.